The secant and cosecant functions are just the reciprocals of the cosine and sine functions, so we can apply the same type of analysis as we did to the cotangent function to get their graphs. Since the graphs are simpler this time, we won't go through as many steps as we did for the cotangent function. Here are the graphs of the cosine and sine functions. The zeros of the cosine and sine functions turn into asymptotes for the secant and cosecant functions. There are no asymptotes for the cosine and sine functions, so we have no zeros for the secant and cosecant functions. Also, the peaks and valleys of the sine and cosine function are at height plus or minus 1, so these points stay fixed when we look at the reciprocals. We'll mark those points and gray out the cosine and sine functions in preparation for graphing the secant and cosecant functions. Recall that we determine whether the reciprocal function is approaching positive or negative infinity by the signs of the original functions. This process will give us the graphs of the secant and cosecant functions. While we could use key values for the secant and cosecant functions to graph transformations, it turns out that we have a helpful heuristic based on the sine and cosine graphs that is a little bit easier to use. The basic idea is that the cosine and secant functions and the sine and cosecant functions transform together. As the zeros of the cosine and sine functions move around, so do the asymptotes of the secant and cosecant functions. As the cosine and sine functions are stretched and shifted vertically, the secant and cosecant functions move with them. This is best understood through an example. Example: graph y equals 2 secant of 2x plus pi plus 1. To graph this function, we start by graphing the corresponding cosine function, y equals 2 cosine of 2x plus pi plus 1. If you need to review these steps, you are encouraged to watch the previous videos which go through these steps a little more slowly. Just as before, we determine the fundamental period and the x-coordinates of our key values. We can then substitute the y-coordinates into the formula to get the transformed y values. This gives us all the information we need to graph the cosine function. To get the secant graph, we first draw the asymptotes through the points where the midline crosses the cosine function. The peaks and valleys of the cosine function become reference points for the secant function. And now we use what we know about the shape of the secant function to sketch the graph. It is important to understand that this works because the two graphs transform together. We are not actually graphing the cosine function and then inverting it to get the secant function. If we did this, the formula and the graph would look quite different. The inversion step actually happens before the vertical stretching and shifting, so we're simply using the cosine function as a reference for the secant function. The same process would work for graphing the transformed cosecant function, except that you would graph a sine function instead of a cosine function as your starting point. Your ability to graph the secant and cosecant functions will greatly depend on your ability to graph the cosine and sine functions. This is another example of how mathematics builds new ideas on top of old ones. If you are struggling with graphing these functions, you might want to go back and review the previous couple sections to make sure that you have a solid foundation to build on.